Hello everyone and welcome to your first video, your first instructional video by me. I wanted to bring your attention to a file I put in the Getting Started module. It's all the derivatives you learned in Calc 1. You'll notice our favorite guy right here, the quotient rule. You got the general power rule, the product rule. Oh, how about this guy, the chain rule? Very important, all your trig ones. And in this video, we're going to look at these ones. Inverse trig functions. Okay, so that'll be our first derivative practice. We'll get out of the way, and everything else you should have seen on here. And then in this document, you also have all your integrals, which, let's see, in Calc 1 you covered some of these, not many of these. Calc 1 you just kind of barely get into integrals, and then in Calc 2 we're going to do all this stuff. Well, a lot of it. Not all of it, but a lot of it. Okay? All right, so I would print that out, keep that handy. So if you forget something, you can say, well, wait a minute, what's the inverse, or what's the integral of secant squared? I think that's tangent, but let me check. Oh, where is it? There it is. Secant squared, they give you like a little more powerful one, kind of like a chain rule version of that, okay, if there's some constant multiple of x. Okay, so what are we going to do in this video? Let's do a really brief review. You do have an assignment that's not graded that reviews in more detail Calc 1, so see if you remember how to do this stuff. So I'm just asking you to do some basic derivatives. In the next video, we'll do some basic integrals, and then we'll learn like a new integration thing. And that'll be it for week 1. Week 1 is review Calc 1, 310 derivatives of inverse trig functions, and then 6.2 area between curves, which also kind of acts as a review of integration. All right, so do you remember this derivative? Find the derivative. Well, I say, oh, that's a composite function, so I know to use the chain rule. So it's a general power rule, which is a version of the chain rule. We bring this down. You leave this alone, you take one away, and then you multiply. If you're ever going to forget anything about the chain rule, it's going to be this piece. You multiply by the derivative of the input function. Move my face out of the way. And that should be 6x minus 5. And that's it. Remember that, hopefully. How about this one? This is, again, a chain rule practice, because you got a function inputted into another function, right? A composite function. So you say, all right, I take the derivative of the sine function with respect to this. That's cosine of 4x cubed, or leave the input function alone, and then multiply by the derivative of the input function, which is 12x squared. Remember doing this, hopefully. Okay, you see this when you say, what rules do I need? You say, I'm going to need the chain rule, because I got e to the x squared, that's composite function. But I'm also going to need the product rule, because I got a product there. So I got a function times a function of x times a function of x. So I leave the first guy alone, take the derivative of e to the x squared. E to the x squared, it's its own derivative, times the derivative of x squared, which is 2x, plus, and then you take the derivative of this one, which is 1, and you leave the second guy alone, e to the x squared. So that's 2x squared e to the x squared plus e to the x squared. And then if we can do some easy algebra to clean this guy up, we usually do that. So I can see I got a common factor, which is factored out. And I get that as my derivative, okay? That is the shortest review of derivatives ever. You're going to do your own review as you work through that assignment that I called Calc 1 review in preparation for Calc 2 or something like that. Okay. It's always important if you have questions to let me know. I can meet with you during office hours and we can go over these. If you're saying, oh, I haven't taken Calc 1 in 5 years, I don't remember any of this stuff, then just shoot me a message or spend some time doing it. If you can figure it out, that's totally fine. If you want to meet with me, that'd be great. Okay. Now to the new stuff. This is actually a topic I was supposed to cover in Calc 1. So I know some of you took my Calc 1 in the summer and it was like really condensed. It was only like 10 weeks. So I left a couple topics out, and I'm using those topics I left out to start Calc 2. So those of you that already saw this stuff, it's just think of it as a review. but also I'm treating this as a Calc 1 review as well, because these are just practice in chain rule, really. Okay, so I'm not going to prove any of these. Sometimes I'll do proofs, sometimes I won't. Sometimes I'll say, well, just take my word for it. The derivative of these inverse trig functions are given as they are. We could do a little. The thing is, with calculus, when I introduce a new derivative, it's probably good to review the function that we're talking about, right? The pre-calc stuff. The only issue is that it takes a really long time, all right? So I don't want to make these videos like 45 minutes long, right? I want to focus on the calculus content. So I encourage you to, if you need to review, my real brief review would go something like this. If you know what your sine function is, right? And you might remember its properties. Whoa, where did that come from? That's a good sign. A good sign, S-I-G-N sign for the semester. Okay, the sine function doesn't look like R. It looks like this. That's not the best graph. That's the cosine function. So let me try that again. That heart really threw me off here. Sine function. Okay, remember all your properties of this guy. It's period 2 pi. That means it starts over again at 2 pi. It starts at 0 and then increases and then decreases, so it has positive and negative values. It's an odd function, etc., etc. If I want an inverse trig function, these ones look really weird, right? You're probably real familiar with your sine function. It has the domain of all real numbers. Its range goes from 1 to -1. If I want to come up with an inverse function, I have to do something. I have to do a little trick. I can say, well, remember that functions aren't invertible unless they're 1-to-1. That is, they have to pass if they fail the horizontal line test, it's not a 1-to-1 function, right? There's multiple outputs for different inputs, or I'm sorry, the same output for different inputs. So that's no good. The sine function does not have an inverse, but we can kind of force it to have an inverse because it's pretty useful to have inverse functions when we get into the calculus. So if I wanted to, or applications, if I wanted to force this to have an inverse function, what would I do? I would make it invertible. That means I would have to stop it right here before I get 2 outputs. And I'd have to stop it right here before I get 2 outputs for, or the same output for 2 different inputs, I should be saying. Right? As soon as it fails the horizontal line test, it's no good. So I would stop it right there and I say, okay, this function is invertible. And it looks weird, right? It doesn't look like the sine function because what makes you think of the sine function is it's the period, right? That just goes over and over again. So this is the sine function where it's invertible. Now I have an inverse sine function. And the inverse sine function, if we use like f of x notation, which we usually do instead of y, then f inverse is the arc sine. And what's true about this function? Well, it flips your inputs and outputs. So if I have a list of outputs here, which I could do, a list of inputs and a list of outputs, then the inverse function just flips your domain and range. Okay, so I won't list all of your inputs and outputs. I'll just say, what's the domain of this function? We restricted the domain to where does it start to do this? Where does the sine function reach a maximum? That's at pi over 2, and this is at negative pi over 2. Okay, so the domain of the sine function where it's invertible is negative pi over 2 to pi over 2. And of course, the range of that just goes from what the range of the sine function is, which is negative 1 to 1. Okay, which tells us a lot about this arc sine function, which you hopefully learned about in a pre-calculus class. That is, the domain of an inverse function is the same as the range. So you can input into your arc sine function anything from negative 1 to 1, and all your outputs will match the inputs of your sine function where it's invertible. So all your outputs would be between negative pi over 2 and pi over 2. So real quick quiz, what's the arc sine of something from its domain? Let's say negative 1/2. Okay, everybody should know this. This is a trig question, which is really important in Calc 1 and Calc 2 and Calc 3 and any calculus class. You ask yourself what angle, if you want, or what input to the sine function has an output of negative 1/2. And it has to be in this sorry, in this range. Your answer has to be in this range. So what angle would satisfy that? Well, it'd have to be a negative angle because only the sine of a negative angle gives you a negative output for your sine function, which is how we're thinking about the inverse sine function, right? I think about this, I don't really say, oh, evaluate the inverse sine function negative 1/2. I say the sine of what? I just think about the sine function. The sine of what gives me negative 1/2, and with this restriction, right? It's an angle. It's an angle in radians. So the answer then would be, I remember I say, oh, sine of, is it 30 degrees or 60 degrees? Pi over 6 or pi over 3? I say, oh, pi over 6. Sine of pi over 6 is 1/2. So it would have to be negative pi over 6. Okay? That's all. That's a real brief review, and that's why I don't do that's like 5 minutes of reviewing old stuff, okay, which I'll do when I can, but I can't spend too much time doing that. So if you don't remember your prereq stuff, look back on it, like go into your textbook or look it up online, say give me a quick review, like on YouTube, quick review of inverse trig functions. Okay, it's pretty useful to know, of course, before you do the calculus. Or you can meet with me. I kind of think of it as like outside of class. Meet with me outside of class and we'll talk about old stuff. Okay? But I'll try and do like a little review, time permitting, before we dive into the calculus. Okay, now for the calculus. So the calculus says, and like I said, I won't do the proof for these. You can look them up. They're not that bad. They are interesting derivatives. You don't often get derivatives of functions that are trig or like a certain category, like derivative of trig function you would think would be another trig function. But in this case, the derivative of these trig functions or inverse trig functions are algebraic functions, which is pretty interesting. It's like the log function. Derivative of the log function, what do you get? Derivative of natural log is 1 over x, right? You get an algebraic function or a rational function. Okay, but all I'm going to ask you to do is take some derivatives. Okay, so this is really just an exercise of applying formulation, really, applying formulas, right? If you notice, so on your formula sheet, you should have, let's look at it real quick. So I would do this, like I'm not expecting you to memorize these. I'll let you use this formula sheet on your test. So if I ask you, test 1, question 1, find the derivative of the arc sine, remember inverse sine, arc sine means the same thing, of the arc sine of, let me see, I got an example. Oh, I didn't want those solutions. Solutions gone. So you say, all right, your first question on test 1, find the derivative of the arc sine of 3x squared, and you don't have the arc sine derivative memorized. That's okay, because I'm going to let you use your formula sheet. Now on your formula sheet, so there's always 2 derivative formulas, right? You might remember this. There's the derivative formula for like the basic one. Let me do one that you know. It would be like if I said, let's do exponential. There's a derivative formula for e to the x. Right? It's e to the x. And then with that, you always get the chain rule version. And that's if it's e to some power of x up here. It could be e to the f of x, or a lot of textbooks use u, and you always assume u is a function of x, so u is f of x. And then what's the derivative of that? Well, it follows this rule and then use the chain rule. So it's e to the u times u prime, or the other notation for u prime, of course, du dx. Okay, so you could write the chain rule version of this, right? It would just be, what's the derivative with respect to x of the arc sine of u, where u is a function of x? Well, it's 1 over the square root of 1 minus u squared times u prime, right? And you might write it, because if you times u prime, be u prime in the numerator. Okay, let's take a look at your formula sheet and see what they do. So on this formula sheet, I just have the x's, and I think that's okay. I hope that makes sense. Some formula sheets will give you the u. I kind of like this formula sheet, and then just understand that you have to know that for every single one of these, you have to know the chain rule equivalent, right? Does this make sense? If I say, what's the derivative of the cosine of, like, say it was like 6x squared? Well, that's a function of u. So the derivative of the cosine of u follows this rule. It's negative sine x, or negative sign u times u